Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little more chemistry with the Batty Boffin, and we're looking at the periodic table and the group 7 elements. Here's a quick reminder of where they come. Now, in earlier videos we've been looking at some of the reactions of the halogens, and we've looked at the electron structure and we've looked at the tendencies as they go down the groups. In this one here we're going to be looking at the bonding, and it's really rather interesting. Well, it's not as interesting as, say, like, being there at the Olympic Games or watching a space shuttle take off or anything like that, but it's still quite interesting as far as these things go. Now, just as a quick reminder, I've got here a fluorine nucleus, and I'd like to put some of the orbitals round it with the electron structure. Little quick reminder, fluorine is element number 9, which means it has an electron structure of 2, 7. So, your turn. Pause the video and draw in the orbitals of the fluorine, please. Right, fluorine is on level 2, period 2 of the periodic table, which means it has 2 orbitals. So here they are, drawing them in. So 2 on the inner orbital and 7 on the next one out. Hopefully you will remember from the orbitals here that the inner one holds 2, the next one out holds a maximum of 8. This one's got 7, so it's nearly full, which means it's desperately keen to get another electron in that outer orbital. Full outer orbital equals happy atom. That's assuming that atoms have emotions. So, how are we going to get that extra electron? Well, there are 2 ways of doing it. Hopefully, one is springing to mind. We just need one more electron from somewhere. So, let's nab it from somebody else. If you add an extra electron, here's an electron, they all have negative charges. If you add an extra electron from somebody else, you've then got a full outer orbital. But you've changed your fluorine slightly. Fluorine is item number 9, which means it has 9 protons. So in the centre here is a 9 pluses. Protons have a positive charge, so 9 protons have 9 positive charges. And around the outside, how many electrons do we have? That's 9. And that extra one makes 10. So here we don't have a fluorine atom, we have a fluoride ion, F minus. Okay, it has 1 extra minus in it, so it's now a charged particle. It's not an atom. Atoms are neutral. Ions, I'll just write it down here. This is an ion, which is just an atom with a charge, positive or negative, in this case negative. So that's fine, but where's it got that electron from? Well, if you have a quick look at the group 1 elements, here they are. Those all have 1 electron in the outer shell. So, here's another one for you to do. I'd like you to draw, please, that's how we have lithium. Let's draw lithium. So I'll put it here. Li is the symbol. That's the nucleus. So could you please pause the video and draw the electron structure around lithium? Right, lithium is also on level 2, period 2, which means it has 2 rings, and it's item number 3, hydrogen, helium, lithium. It's the 3rd element, which means it has 3 protons and 3 electrons. Here they are. Lithium also wants to have a full outer orbital. There's no way it's going to get 6 extra electrons. That just ain't happening. So instead, it gets rid of 1. Getting rid of that, which means it has just then those 2, which is then the outer orbital. This outer one disappears entirely. And that, of course, leaves another charged particle. Lithium is the 3rd one, so that has 3 plus, and 1, 2, 3 normally on the electrons. But when you get rid of that one, now only has 2. So overall it has a positive charge. So that is the fluoride ion and the lithium ion. That one has a negative charge, that one has a positive charge. Positive and negative attract. And this is ionic bonding. All the halogens will work this way. You can have, this is lithium fluoride, this would be called. You could have, instead of lithium, you could have something else in group 1, like say sodium. So you could have sodium fluoride, and instead of the fluorine you could use something like chlorine if you wanted. Sodium chloride. Oh, we've heard of that one, that's salt. In fact, lithium fluoride is another salt. It's kind of, you probably wouldn't want to put it on your chips, but you know, it's a similar kind of thing. So all of these fluorines, chlorine, bromine, iodine will all form 1 negative ions and bond nicely 1-to-1 with the 1+ ions, or they can bond with the group 2s, which form 2+ ions. So you'll get other things down there which will actually take, you know, 2 chlorines and 1, I don't know, hydrogen, helium, lithium, beryllium, chlorine and beryllium. You could mix those two, should you wish. I don't know. Lots of different things. So this is your ionic bonding. Anything that will form a negative bond, which is the halogens, with anything that will form a positive ion, which is the group 1s and the group 2s generally. So that's ionic bonding. Go and get yourself a cup of coffee. I've got mine here. I'm going to wipe down the board and then we're going to do the other type of bonding. Back in a minute. Hi there, welcome back. Right, here's my fluorine as before, and I've drawn another fluorine just next to it, but I haven't put the electrons in yet. Because here we're going to look at, rather unusually, a different way of bonding. Generally, things either form ions, which tends to be the things like over there and over here on the periodic table, or they form covalent bonds, which tends to be things more like carbon in the middle in there. Fluorine and chlorine, bromine and iodine will actually do both. Oh yes, they'll do ionic bonding, like we've just seen, forming ions, and this is covalent bonding, where they're kind of being a bit more cooperative and sharing. You can remember that, covalent is like cooperative, we're sharing things, and sharing is good. Particularly when somebody else has got chocolate and I haven't. So, here's a fluorine, and I've drawn the other one in red just so you can tell the difference, and I'm going to use a red pen here. So could you please get out your pen and paper, copy out this diagram, and then fill in the electrons on the second fluorine. Now you'll just note that I've actually drawn them in pairs here, okay? Electrons tend to hang, well, we say they tend to hang around in pairs. This is a model we're using, okay? They don't actually go around in 2s like little kind of primary school children in a crocodile, but for the moment let's just draw them like that. So could you please draw these in and draw the pairs and watch what happens there. Pause the video, do that now please. Here we go, your diagram should look something like this. So, here we've got a fluorine drawn in blue with an electron arrangement 2-7, and here we've got one drawn in red with an electron arrangement 2-7. But just hold your horses a minute. Have a look at the outer orbital of here. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons! Wahey! The blue one also appears to have 8 electrons. Now, okay, I know there aren't actually 16 electrons in the outer orbitals there. There's only actually 14. But this blue one can see 8 electrons. Happy. This red one can see 8 electrons. Also happy. So here we have got F2. Nobody's forming ions. This isn't an ionic compound. This is neutrally charged. There's no charges happening here. We've got a 9+ in the middle and a 9- on the outside, a 9+ in the middle and a 9- on the outside. But yet each fluorine feels like it's got 8 electrons in the outer orbital and is therefore happy and is therefore stable. Hence you have fluorine goes around as its rather poisonous, nasty gas as F2. It is a diatomic molecule. Here's that long word written out for you. Diatomic, dead easy. Di meaning 2, atom, 2 atoms, yeah? Diatomic molecule. An awful lot of gases hang around in diatomic molecules. It's very, very popular. It is the way that all the cool gases are, you know, H2, O2, FL2, F2, Cl2, all that lot. All hang around as diatomic molecules. And this is a covalent bond. Here it is written out. There we go. Covalent bonding. All the halogens will bond in this way, and it's really quite unusual to have things that form both ionic bonds and covalent bonds. That's a bit unusual. It is the exciting thing. Not as good as a space shuttle launch, but it's the best you're going to get in this video. So, hope you're happy with that. Chlorine, fluorine, bromine and iodine all form ionic bonds and covalent bonds. So I think that's about it from the halogens. I'll see you next time, maybe for the noble gases. Ooh, posh. See you next time, Batty fans.